Yesterday we have seen the linear combination, which is going to be linearly dependent and the linearly independent vectors. Linearly dependent vectors, they form a linear relation between the vectors, and linearly independent vectors, they cannot form a linear relation between the vectors, but being linearly independent, if the linear relation is also given, then each of the scalar must be 0. That's what we have seen yesterday. And also we understood that all the collinear vectors or parallel vectors are linearly dependent and all non-parallel vectors are linearly independent. Similarly, all coplanar vectors are linearly dependent and all non-coplanar vectors are linearly independent. We have seen these concepts in the previous class. Now, in continuation to that, let us work out the problems based on that linearly dependent and independent vectors. Okay, now let us see that 14th problem, please. This is Kaushik, please read that.
Sir,
please read example 14 there.
The point where with position vector 60i plus 3j, 40i minus 8j, ai minus 52j are collinear if k equals to.
First of all, you tell me, we talk about the collinearity
Yes,
of
sir.
2 points, or at least 3 points. Do you understand what I'm saying? My question to you, you tell me whether the collinearity is to be checked for 2 points or minimum of 3 points.
Sir, collinearity is minimum of 3 points, sir.
Minimum of
3 points.
Why?
Sir,
Why is it so?
I didn't get it, sir.
Why not for 2 points?
Sir, we cannot define collinearity for 2 points, sir.
No. Praneeth, your answer, please.
Sir?
Your answer, what the question I asked him is that, do we find the collinearity of 2 points or at least 3 points? It should be at least 3 points, please.
3 points, sir.
2 points are always collinear.
ABBC.
Kaushik, your answer must be like this. 2 points, you need not have to check for the collinearity. 2 points are always collinear. And whether the third point is lying on the line joining the other 2 points or not is the question here. Similarly, coplanarity is to be checked for 4 points, but not for 3 points, because 3 points will always be coplanar. Okay, now here you can proceed with the determinant form, or otherwise you can even go for the area of the triangle, because it is I bar, J bar means it is a 2-dimensional plane. You can simply follow the concept of the slope also. Okay, now let us write the determinant. That will be easy for you. Let me write that. This is det of, because they are collinear, the determinant obviously becomes 0, and it is 60. 3, 1, 40, minus 8, 1, a minus 52, 1 is equal to 0. Are you there, please?
Yes, sir.
Implies 60 into minus 8 plus 52, 44. Okay, then minus 3 into 40 minus 8 plus 1 into, this is minus 52 into 40, please. 52 into 40. 2080 plus 80. Must be 0 if they are collinear. Correct? Now this is 60 into 44. 24 plus 2, 26. 2640 minus 120 plus 38 minus 2080 plus 80 is equal to 0. Come on, tell me, please, simplified form of it. 11a. Come on, you simplify and tell me here, please.
Yes, sir.
This is minus 120 is there. Minus 2200. I think 2640 minus 2200.
Minus 2200.
Minus 440 is 11a is equal to minus 440. A is equal to minus 40. This is simply
40,
using
40, sir.
Is it 40 or minus 40?
Minus 40, sir.
Minus 40.
11A, I asked. Minus.
So A is minus 40. So this is a way you can make use of collinearity in the form of the determinant. Or otherwise also you can go for linear combination. Linear combination also can be written like what? You can go for linear combination like this. If you take these points as A, B, C, then you can write it as AB bar is equal to lambda into AC bar, and you can compare on both sides, and thereby you will get the value of lambda, and therefrom you can get the value of A also. This is another method. And because this determinant method is easy, we have taken it up. Okay, I'm proceeding to the next problem, please. I hope you understand this.
Yes, sir. Understood.
Next. This is, just see the method what he did also. As 3 points are collinear, he wrote a linear combination. He wrote a linear combination. Just so check it out, because if it is somewhere, if you come across this method, you should not feel it new. He wrote a linear combination between these three vectors such that x into a bar plus y into b bar plus z into c bar must be 0 bar, such that x, y, z are not all 0, x plus y plus z is equal to 0. Then he has taken I bar, j bar common, and he compared on both sides, and thereby he got 3 equations in x, y, z, and of course he did the same. He did the same. Okay, we have written that step directly. Similarly, what the, yes.
I'm gonna keep my microphone muted, sir. Some work is going on around, so disturbance.
Okay. Similarly, the linear combination can be written AB bar is equal to K into BC bar, and thereby here also you can find out in the same way. Next one is 15. Rinit, can you help me out in writing those points? You can read the coefficients there. A, position vectors of A, B, C, D. Please read that, Pranit. 2, 1. What is B? 1 minus 3. What is C? 3, 2. And what is D? 1 comma lambda. AB bar parallel to CD bar given. Are there both of you? Pranit?
Yes, sir.
So 4 points are given, and it is also given that AB bar is parallel to CD bar. Whenever 2 vectors are parallel, there exists a linear relation between them.
Yes, sir. A bar equals to lambda b bar.
AB bar, in this case, AB bar is equal to lambda into CD bar. Correct? So let me write AB bar, please. OB minus OA, come on, 1 minus 2, minus 1, this one. And minus 3 minus 1, minus 4. I'm presenting them in terms of coordinates as an ordered pair, is equal to lambda into CD bar, please, CD bar OD minus OC. This is minus 2 comma lambda minus 2, which implies that minus 2 lambda is equal to minus 1. Let us compare it. Minus 2 lambda is equal to minus 1. And minus 4 is equal to lambda square. And because he used lambda, we should not use it. So let me change this lambda to some other t. Do you understand what I'm saying? Because lambda is already used by.
Yes, sir. Yes, sir.
So let me convert this as t. So this becomes minus 2t. And it is minus 4 is equal to lambda into lambda. My minus 4 is equal to t into lambda minus 2. Now I have to solve this to get the value of lambda. Here t is equal to 1 by 2. And substitute here, minus 4 is equal to 1 by 2 into lambda minus 2. Now this is minus 8 plus 2 minus 6. Lambda is equal to minus 6. That's it to be find out, I think. Just check it out. Lambda is equal to minus 6. I hope you understand what I wrote there, because they are parallel. There exists a linear relation between them. AB bar is equal to T into CD bar. This is what you have to understand. Okay. Let's move on to the next question. Yeah, this is also the important model. Please read that, Kaushik.
If the position vectors of A, B, C, D are 2i plus.
Just now we did it.
Sir, 1 minute.
Next one, 16.
Let A, B, and C be 3 non-zero vectors such that no two of these are collinear. If the vector A plus 2B is collinear with C and B plus 3C is collinear with A, lambda being some non-zero scalar, then A plus 2B plus 6C equals.
Okay, if the vector A bar plus 2B bar is collinear with C bar and B bar plus C bar is collinear with A bar, B bar plus 3C bar is collinear with A bar, and lambda being some non-zero scalar. Where is lambda given here? Okay, in the options it is given, lambda being non-zero scalar. Then the question is, what is asking is A bar plus 2B bar plus 6C bar is to be found out. Just say this, please. This is very easy. And also it is a previous question. Just follow this carefully. What he's saying is, he's saying that this A bar plus 2B bar is collinear with C bar. When it is collinear with C bar, definitely there exists a linear relation between these two such that there exists a scalar in between them. I'm saying it as some S here. S is a scalar. So A bar plus 2B bar is equal to SC bar. Similarly, B bar plus 3C bar is collinear with A bar, and there exists a linear relation between them such that B bar plus 3C bar is equal to T into A bar. T into A bar. These are the two relations given by him, and he needs the value of this. A bar plus 2B bar is equal to 6C bar. Okay. Now, let us make use of these two to find out its value, like how we do. And we simply substituting, we are substituting first equation in second equation, or second equation first equation, whatever you do, no problem at all. So 1 into implies, come on, tell me please, B bar plus 3C bar is equal to T into, come on, tell me A bar please from the first one.
Sir, A bar.
Yes, C bar.
S in C bar minus 2B bar.
Correct. Now, on comparison, come on, tell me this. B bar coefficient is 1, and here B bar coefficient is minus 2T. That is, you got the value of T as minus 1 by 2 here. C bar coefficient is 3, and C bar coefficient is TS here. From this one, what is that you get? T is equal to minus 1 by 2. And S is equal to, you have got both the values now. S is equal to 3 by T. 3 by T means 3 by minus 2. S is minus 6. Now simply substitute S value in this one. Come on, tell me what is the final result now?
Sir, A bar. No.
Yes.
A bar plus 2B bar equals to minus 6 in C bar.
So what is the answer now? That's it. He needs that only. We have got it to be 0 bar. Just write it out. A bar plus 2B bar plus 6C bar is equal to 0 bar is the final answer.
Yes, sir.
Now, let us move on to the next question. I think it is clear.
Yes, sir. Yes, sir.
Praneeth, are you there? Next one. Now, the next question is on coplanarity. Next question is on coplanarity. If the vectors, this one please, I'm talking about this one.
Sir, shall I read it, sir?
Huh.
If the vectors 4i plus 11j plus nk,
Let me write
11i
one moment. Let me write 4, 11, m. Yes.
7 to 6 and 7i plus 2j plus 6k.
Huh.
And I plus 5j plus 4k
Okay.
are coplanar, let M is.
Praneeth, any internet issue?
Yes, sir.
Okay.
So I
Now,
logged in
let's
from
see
another.
this is a simple question only. What the question we did also, it is based on collinearity in the table. And that's also an important question. I must have taken the screenshot of it. Okay. This is if the vectors, I'll come to that question again for you. If the vectors are coplanar, then M is. Coplanarity exists only when there exists a linear relation between them. Or otherwise, because these are given to be vectors only, don't forget, these are not points here. He's saying that these are vectors. When these are vectors, straight away find out the determinant. We are following the easy methods only. And even you can write the linear combination and you can solve it, but that also gives you the same value. What is that given here? Just check it out. If you see the question, if the vectors, he's saying that if these are the vectors. So vectors, if vectors are given, 3 will be given. If points are given, 4 will be given. Understand that, Kaushik? If the points are given, 4 points will be given. If the vectors are given, 3 vectors will be given. If 4 points are given, you have to make those 4 points as 3 vectors. That's what you have to understand. Here, 3 vectors are given. It is straight question. So implies that this determinant becomes 0. Straight away. Come on, you help me out in solving this determinant, please. Come on, you work out. Pranit, please work out this. 4, 11,
M 76 1.
7, 2, 6, 1, 5, 4. Must be 0. Then what will it be? This is 4 into, I'm writing directly, 8 minus 30 minus 22. So 4
Minus
into
20.
4 into minus 22 minus 88. I'm writing
88.
6 minus 28 minus 22. 6 minus 28 minus 22 into 11.
Minus 21 minus 11. 21 minus 6, sir.
22.
Minus 11 into 21 minus 6.
Yeah.
15. 11, 15.
And similarly, 35 minus 2. 35 minus 2, 33. So 33m is equal to 0. So you will have this as 33m is equal to, how much is this? 10, and it is 12, 13, and 330. And your m is nothing but 10. Simple questions only we have taken up because it is the beginning. So when 3 vectors are coplanar, you have to understand that the determinant becomes 0. I think it is clear. I need not already explain you more. It is simply solving the determinant. Okay. I'm moving on to the next question now. And linear combination can also be found out. If you want to write the linear combination, how to proceed with, then you take this as A bar. Take this as B bar. Let me change the color. One moment. Take this as A bar. Take this as B bar. And take this as C bar. And write a linear relation between them. A bar is equal to XB bar plus YC bar. Then solve for X and Y. And in that X and Y only, you will be getting M value also, like this. But in comparison and all, it will take some time. And hence we follow the determinant method. But you must also understand the linear combination method also. Okay, I'm erasing this, erase to this. Now let us move on to the next question, please. 18, please. 18. Now, can you read this, Pranit?
Sure.
Can you read this, please? You tell me as points, that will be better. Let me write this as A. Come on, tell me the first point, please. I'll be writing it here.
2
3
minus 1.
Yes. Next.
B is 1, 2, 3, sir.
That's good.
C is 3, 4 minus 2.
Okay.
D is 1 minus lambda 6.
That's good. What he's saying is they are coplanar. Just now I said, Kaushik, if there are 3 vectors, we talk about the coplanarity. If 3 points are there, 3 points will be obviously coplanar, but if the points are given, you must understand that 4 points must be given for coplanarity. That is the reason why he gave 4 points there. Now we are now proving. We are not now proving. They are. It is given that they are coplanar. It is given that they are coplanar. So what is to be done now? What is to be done? Now you have to convert them to 3 vectors like this. How? Come on, tell me AB bar, please. AB bar is OB minus OA. I'm writing that 1 minus 2, minus 1, 2 minus 3, minus 1, 3 plus 1, 4. We have got AB bar here. Similarly, could you tell me AC bar, please? AC bar, OC minus OA minus 1, and it is 4 minus 3, 1. It is minus 2 plus 1, minus 1. Do tell me AD bar similarly.
Sir,
Yeah.
with me or print, sir?
Pardon me?
Minus 2.
AD bar, please. 1 minus 3.
AD bar, sir. Okay, sir. Minus 1.
Yeah.
Minus lambda minus 3.
That's good.
Minus 7.
7. When 4 points are coplanar, their corresponding vectors are also coplanar.
Coplanar.
Correct, no, Pranit? Now, what is to be done? You have to simply find out the determinant of this.
Yes, sir.
Come on, let us find out the determinant. Come on, you also work out along with me. Straight away writing the points, that's it. Straight away you have to write the points. -1, -1, 4. And -1, 1, -1. And -1, minus lambda, -3.
7.
7 is equal to 0. Please solve it and tell me the answer. I'll wait for you. Come on, both of you. Solve it for lambda. Yes. Any one of you, do tell me this is minus of 7. Minus of minus, that becomes plus there in
The
the
lambda equals to -2, sir.
-2 now.
Yes, sir.
-7, -1, -8 plus 4 into lambda plus 3 plus 1 equal to 0. So it should be 7 minus 3, 4, 4 minus 4 minus 4 minus 12, minus 12 plus 16. 4, and it is lambda plus 4 lambda, 5 lambda. I'm getting a different answer. Kaushik, lambda plus 4. Anyway, I have to check the simplification also once. Pranit, just check it out. Minus of 7.
-2 only, sir.
Minus lambda minus 3. And it is plus 1 into -7, -1, -8, correct only. And here it is plus 4 into lambda plus 3 plus 1. Let me see the simplification.
Sir.
Just more. Let me see.
Yes, I think that's minus of -8, sir.
This one, huh?
Yes, sir.
This becomes plus 1, no?
No, sir.
So plus,
Yes, sir. Yes, sir.
correct. That's -8. So -7, -8, -15, -15 plus 16, -15 plus 16. So 1. This is 1. Pranit, what is your answer, please? This is lambda plus 4 lambda, 5 lambda. So your lambda must be -1/5. Let us check the option once. Or coplanar, then M is this one, no? But nowhere the answer is. It is given to be -2. So we have gone somewhere wrong. Let us check it out.
Even I didn't get the answer, sir.
That means we have written, I think we have written the vectors itself wrong. Let me check. AB bar, please. 1 - 2 -1, 2 - 3 -1, 3 + 1, 4. That's correct. And AC bar, please. 3 - 2. Oh, this is wrong. AC bar.
+1, sir.
Oh, +1. And it is 4 - 3, 1 - 2 + 3 - 1. That's correct. AD bar, you said this, I think it is correct. -1 minus lambda -3, 6 + 1, 7. This is all correct. And this becomes +1. Now I think you will get it. So what happens here? +1 into 7 - 1, 6. This is 6. Okay. Now 4 into minus lambda -3. Minus lambda -3 +1. That is correct. +1. Now simplify this, you'll get the answer. So check with a simple mistake in the sign has changed the entire problem. Just understand that. 7 - 3, 4, -4 + 6, 2. 2 minus 8 -6. And this is -1, -1, -8. So let's write the constant here, please. -7 plus 7 - 3, 4. -4 plus 6, 2. 2 minus 8, -6. And now this is lambda minus 4 lambda. This is lambda minus 4 lambda. -3 lambda.
Sir.
Lambda is equal to -2. Is it the answer given or +2 given?
-2.
No, we have got -2. That's okay. But let me check the answer once. It is -2.
Answer also is -2, sir.
Right. Now, just a mistake in the sign. Now this is okay.
Sir, we have to be very careful by solving these vectors, sir. One sign mistake can change everything.
Yeah. It's clear now. So what we did, we are given 4 points. We converted them to 3 vectors and we got the determinant. This is easy method. And if you want to follow the linear combination method, that is in fact lengthy, but whenever some passage questions or something like that are given, then you must be in a position to understand what exactly it is. Then if you want to write a linear relation now, then you have to write in this way. You have to write in this way. Like what you must write as AB bar is equal to X into AC bar plus Y into AD bar. This is the method to write. Then we will compare on both sides and then we will be getting the values of X and Y. This is the method you have to understand. Okay, now we have followed the determinant method. This determinant method, in fact, you will be getting in the triple product, scalar triple product. Okay, now that is done. Let us move on to the next question. This is a little different question because you are given the length there. Kaushik, please tell me the date. I'll be writing that.
If A equals to I plus J plus K, B equals to 4I plus 3J,
triple one. Okay.
yes, sir, plus 4K, and G equals to I plus alpha J plus beta K are linearly dependent
No,
vectors.
no, no. B tell me, you tell me B
4,
first.
3, 4, sir.
4, 3, 4. Okay. Then
1 alpha beta.
that's good.
Are linearly dependent vectors, and mod C bar equals to root 3.
Linearly dependent. And mod C bar is equal to root 3. Then what is it we find out?
Then alpha and beta values.
Alpha and beta values. First of all, you tell me what is the meaning of linearly dependent vectors, please? Any one of you? What is the meaning of linearly dependent vectors?
Then
What is the meaning of, he gave that they are linearly dependent. What is the meaning of linearly dependent vectors? My question to you, what is the meaning of linearly dependent vectors?
no,
There
sir.
is a linear
Sir,
relation. Correct, no?
sir,
Linearly dependent means there
sir, vector. I mean, yesterday we did know, sir, if a set of vectors are said to be linearly dependent, if they exist a scalar x1, x2, so on, not all the zeros such as x1, a1 plus x2, a2 plus so on, xn, an equals to 0.
perfect. Perfect. That means there exists a linear relation between them. If
Yes,
they are linearly dependent, there exists a linear relation between them. And also, you have to understand that. And also, you have to understand that if they are linearly dependent, obviously they are coplanar.
Yes, sir.
Coplanar. So, you can go for the determinant method. Determinant method. I said no, that will be easy for you. That will be easy for you. So, let us follow that only. So, let me write, because they are linearly dependent, the determinant must be 0. Do you tell me the determinant elements here? 1, 1, 1, 4, 3, 4. And here 1 alpha beta. Must be 0. Correct? Which implies that 3 beta minus 4 alpha, 4 minus 4 beta, and 4 alpha minus 3 must be 0, since they are linearly dependent. Let me write alpha first. 4 alpha getting cancelled. Of course, you're getting beta directly. It is easy. It is easy because you're getting beta directly. What is the value of beta here, please? 3 beta minus 4 beta minus beta. Get it to other side. Plus beta is equal to 4 minus 3, 1. So beta value is 1. You have got the value of beta now. And we need the value of alpha also. We need the value of alpha also. For that purpose, what is to be done? Just he has given an extra information that the length of C bar is root 3. Just check it out, please. Check the question. It is given that the length of C bar is root 3. Now, do you tell me what is mod C bar then? What is mod C bar? Any one of you? Mod C bar is equal to root 3 given. From this one, I'd like to write mod C bar. What is C here? C bar here, 1 alpha beta. Come on, tell me modulus of it. Kaushik and Pranit. 1 square plus alpha square plus beta square.
Beta square. Yes, sir.
Is equal to 3.
Yes,
Squaring on both sides. But what is beta value, please? 1.
sir.
So 1 plus alpha square plus 1 is equal to 3, implies alpha is equal to plus or minus 1. So you've got both the values now.
Sir.
Alpha value is plus or minus 1 and beta value
Beta is 1.
Which is required to be found out.
Okay, sir. Here, sir.
Okay, now let's move on to the next question. Now we are entering into product of two vectors. Okay. So in the product of two vectors, this is scalar product or dot product or inner product. We call it as inner product also. See, there are two types of product of vectors. There are two types in the product of vectors. Number one is, so I'm writing that here, product of vectors. In the product of vectors, the heading itself, there is an importance for this. Whatever the product we are writing, it is defined only for vectors, don't forget. Further in triple product, it will be useful. Further in triple product, it will be useful. So, how is it defined now? There are two types of products here of vectors. Number one is scalar. Or it is also said to be dot because it is denoted by dot or dot product. Dot product, or it is also said to be inner product. It is not used much, but it is also said to be inner product. And number two is vector product. It is also said to be cross product because it is denoted by cross. Okay, so why these are named as scalar and vector products? Scalar product will result into a scalar and vector product will result into a vector. That is the reason why they are named like that. So let us check the scalar product first. So how is it defined? Now this is A bar dot B bar. A bar dot B bar is defined as modulus of A bar into modulus of B bar into cos theta, where theta is equal to angle between A bar and B bar. Theta is equal to angle between A bar and B bar. Please, are you there, both of you?
Yes, sir.
This is not new to you. You might have applied this frequently in physics also. So dot product, you have to understand, the result is a scalar and hence it contains only the magnitude but no direction. Because there is no direction, it is named as scalar product. So A bar dot B bar is equal to mod A bar into mod B bar into cos theta is a scalar product. Now theta is nothing but the angle between the two vectors. We will see the geometrical meaning of this. That is called geometrical interpretation. Let us understand the geometrical interpretation also. But before that, let us understand the negativity and positivity and the zero of this scalar product or dot product. That means, what I mean to say here, if you take theta, theta may be lying between, angle between two lines always lies between 0 and 180 degrees. Similarly, angle between two vectors also lies between 0 and 180. So minimum is 0 degrees and maximum is 180 degrees. So angle between two vectors is always lying between 0 and 180, and below 0 and below 180 again it takes the same form only because in the cyclic way, because these are taken to be two lines, and whatever the angle is there, that lies between that lies either in first quadrant or second quadrant. So we have to discuss about the scalar product between these limitations only. So let me start with theta 0 first. Number one case, theta is equal to 0 degrees, implies it is cos 0, please, cos 0, 1. So A bar dot B bar is equal to mod A bar into mod B bar. So this is what you have to understand. So when the dot product is straight away the product of their magnitudes, when the dot product is straight away the product of their magnitude, you have to understand that angle between them is 0 degrees. That means they are coincident. They are coincident or parallel vectors. They are coincident or parallel vectors. Now similarly, if theta is lying between 0 and 90, that is theta is an acute angle. Any one of you please tell me the sign of A bar dot B bar? Respond please. Anyone? Yes. Yes, please. Theta is in the first quadrant, then what will be cos theta? Positive?
Positive.
Positive. Then in that case, what happens to A dot B? It is all obviously greater than 0.
Greater than 0.
That's what I expect from you. If theta is in the first quadrant or theta is an acute angle, the dot product obviously positive. So you can confirmably say that if the dot product is you got it to be positive, then you can confirmably say that the angle is an acute angle. Now let us go to the next case. Kaushik, do you tell me what should be the third case then?
So, so greater than.
No, I wrote that. Theta 90 degrees, I have not taken it here. Theta 90 degrees, then what will be the dot product, please?
0. Sir, theta 90 degrees 0.
It is the most important case. If you want me to give the star rating to this one, I'll give 4 stars to this one. I'll give 4 stars to this one. That much important it is. The 5th star, it is your choice. After you do the problems, you will understand whether 5th star is to be given or not. So that much important it is. Wherever the perpendicularity case comes, you have to find out the dot product. So dot product 0 means the angle between the two vectors is always 90 degrees. Now let me understand the 4th case from our darling. Who is darling there? From our darling Pranit. That is 90 degrees is less than theta, less than 180 degrees. Pranit, Babu. If theta is lying in the second quadrant, then what should be the sign of cos theta, please? Sign of cos theta. Theta is going to be lying in the second quadrant. Less than 0. So if you get that the dot product is negative, then your theta becomes obtuse angle. If the angle between the vectors is obtuse, then the dot product is less than 0. Remember that. We will be understanding, of course, the geometrical meaning of this. We'll be understanding that further. Now, what else is remaining in this range here? Everything is discussed. 0 discussed, 0 to 90 discussed, and 90 discussed, and 90 to 180 discussed. But Only one is remaining. What is that, please? Theta is equal to 180 degrees is remaining. And do you tell me what is A bar dot B bar then? Any one of you? Theta 180 degrees.
So theta 180 degrees, 0, 1, 1, minus of A bar.
Correct. Minus mod A bar into mod B bar. This is what you have to understand, please. Okay, so this is what to be understood. Minus A bar dot B bar. If you are getting the dot product of two vectors as a negative sign of the product of their magnitude, negative of product of their magnitude, then you have to understand that the angle between them is 180 degrees. What does it mean? How do you see them geometrically? How do you see them geometrically? Geometrically, you can understand like this. If the angle between them is 0 degrees, they are parallel. That means this is one vector. This is another vector. Obviously, they are parallel. And if the angle between them is 90 degrees, how the vectors will be? The vectors will be like this. This is angle. This is one vector. And this is another vector. Angle between them is lying between 0 and 90. And what about theta 90 degrees? I need not have to say that. You will understand the angle between them. I gave 4-star rating for that one. You can give even 5-star rating also. That much important it is. In case of dot product, the most preference is given to the perpendicular vectors. And even in the problems also, you will have more and more applications of it. So the two vectors will be like this. They are perpendicular to each other. Dot product becomes 0. And in case of A dot B less than 0, how the vectors will be? The angle between them will be obviously greater than 90 degrees. And hence they are like this. Greater than 90 degrees. And hence they are like that. Okay. So this is to be understood carefully. Similarly, if the two vectors dot product is negative sign of product of their magnitude, negative sign of product of their magnitude, how the vectors will be? Kaushik, how the vectors will be in this case? They are exactly opposite in direction. This is what you have to understand. Kaushik,
Sir,
are you there?
yes, sir.
When they are exactly opposite in direction, then the angle between them will be obviously 90 degrees. Sorry, 180 degrees. Obviously, the angle between them will be 180 degrees. Then in that case, it is negative of the magnitude product of their magnitude. So this is about the dot product introduction. Now we will be saying the geometrical interpretation or geometrical application of a scalar product. Geometrical application of scalar product. Let us see that. Let us see that. Now, Pranit, you tell me whether you're comfortable with this or not. Pranit.
Sir, comfortable, sir.
This is very simple concepts, and I need not only explain you more, but whenever you see these dot product values, you must be in a position to understand the angle between the vectors. And according to the value of dot product, you can say the angle between them. According to the angle, you can say the dot product value.
Not going between them, yes, sir.
Okay. So,
Both of them are into.
what is which topic is going on now for you in the class, Pranit? Vectors.
So product of vectors. Sir.
Product of vectors, okay. Next, geometrical. Interpretation. So generally what happens now, whenever you are learning mathematics and whatever I explain you, whatever the teacher explains, mathematics teacher, the students think that it is just a mathematical formula, but there will be definitely geometrical meaning and there will be definitely an application for that. Without that, we don't learn anything. Similarly, what is that we are trying to learn here? We are just checking the application, geometrical application of this dot product. What is the dot product here? Just now we have seen the definition. A bar dot B bar is equal to mod A bar into mod B bar into cos of theta, where angle between A bar, B bar we have taken to be theta. Just check it out. Listen to this carefully. It is very easy to understand. Very easy to understand. What is that we are seeing? We are just seeing the geometrical meaning of this. Geometrical interpretation of this. So let me take a vector. There are two vectors here. One vector I have taken to be A bar. And another vector I have taken to be B bar. Now we need the dot product geometrical meaning. Geometrical meaning of dot product. So now if I extend this backwards, let me name this first. This is A bar and this is B bar. Whatever, you can take, you can reverse them also. Like the above one can be taken as A bar, below one can be taken as B bar also, no problem at all. So A bar and B bar. Now, if you extend this backwards, then it definitely meets this vector because they are non-parallel and non-collinear. I have extended this in this way, just to meet the below vector. So what happens here? Why I'm extending it, you'll understand. I want to know the angle between them. I want to represent the angle between them. So this is the intersection of these two vectors when the above one is extended backwards. So below one is unlimited, I have taken. Below A bar, I have taken unlimited. So if I take this angle theta, not if I take, it is taken to be theta there. Then let me check. This is the length of the vector A bar, and I'm representing this with mod A bar. I'm representing this with mod A bar. Do any one of you, what is the meaning of modulus, please, in this case?
So magnitude.
Yes, magnitude means length of the vector. Now I'm drawing a line which is parallel to, just a moment, please. I have to change the below one. By mistake, I have taken both A bar. I'm taking it as B bar. The above one I have taken to be A bar. This becomes B bar. Now, what I'm doing, I'm just drawing a, just a moment, please. Yeah. This is a vector B bar. Now what I'm doing, I'm just taking the projection of A bar on B bar. I'm taking the projection of A bar on B bar. What is the meaning of projection? You have to draw two perpendicular lines from the extremities of A bar onto B bar. That is, this is one extremity. I have drawn a perpendicular here. This is one other extremity. I have drawn a perpendicular here. This is called the projection, please. Projection of A bar and B bar. The meaning of projection, no confusion, please. It is nothing but drawing the perpendiculars from the extremities of one vector onto another vector. The below vector is of unlimited length and the above vector is of limited length. For your convenience, if you want, I'll name them. I'll name them as A, B. A is initial point and B is terminal point. Now, what is the foot of A here? Let me name it as A dash. What is foot of B here? Let me name it as B dash. Now, I want to draw a line which is equivalent to A dash, B dash and parallel to it. That's what I'm doing here now. This is A dash, B dash, equal in length to A dash, B dash. And let me name this as some C. Now understand that this AC is very much equal to A dash, B dash. Do you accept this or not? Kaushik and Praneeth, AC and A dash, B dash are equal or not?
Yes, sir.
Equal, sir.
Now I'm interested in A dash, B dash. Now you tell me, any one of you please, do you tell me what is this angle here? This angle. If this is theta, what is this angle? Because these two are parallel lines.
Theta.
Yes, it is also theta. Correct, no? Now, let me write cos theta in triangle ABC. In triangle ABC, tell me cos theta, please. Any one of you? Adjacent side, AC divided by, come on, tell me, AB.
Yes, sir.
So, what will be AC? Is the orthogonal projection. I can, instead of AC, I can write A dash B dash. Whole divided by, instead of AB, what is that can be written? Instead of AB, what is that can be written? Mod A bar?
Dash B dash.
Mod A bar, no?
Yes, sir.
Yeah. Now, what is A dash B dash here? Mod A bar into cos theta. Correct?
Yes, sir.
So what is the advantage by finding this mod A bar cos theta? Now we can define the geometrical meaning of it. That's what our effort is. What is our effort here? We want to understand the geometrical meaning of the dot product. So I have got this mod A bar cos theta. This one, mod A bar cos theta, as the orthogonal projection of A bar on B bar. A bar on B bar. So now finally, I'm concluding this. Therefore, A bar dot B bar is equal to length of orthogonal projection of A bar on B bar into length of B bar, that is mod B bar. This is the geometrical meaning of A. Understand this. So when you are finding the dot product, you have to understand that. It is nothing but the orthogonal projection of A bar on B bar into length of B bar. It is orthogonal projection of A bar on B bar into length of B bar is the geometrical meaning of A dot B. This is what you have to understand. This is what I'm trying to explain you. See, you tell me whether you understand this or not, or if not, I'll explain it again.
Sir, understood this, sir.
Generally what happens, the geometrical meaning is neglected but it is better you have to understand the geometrical meaning of it. And of course, you might have by hearted. You can by heart the formula in your first year, that is in your 11th class itself. You might have learned this, and you might have applied this many times in physics.
Yes, sir. In
Physics, you might have applied this in many times. Now, here the geometrical meaning of this, geometrical interpretation means geometrical meaning of this is this one. So A dot B means the length of the orthogonal projection of A bar on B bar into length of B bar. Any one of you both, could you please tell me the same? Could you tell me the same with A bar and B bar interchanged? Kaushik and Praneeth. With A bar and B bar interchanged. Understand what I'm saying. First of all, understand what I'm saying.
Yes.
What I mean to say here, I have taken the diagram in such a way that B bar is of unlimited length and A bar is of limited length. Now if I interchange these two, that means I am taking A bar as of unlimited length and B bar is of limited length. Then the geometrical meaning of it or geometrical interpretation changes, how the final conclusion changes. Any one of you, please.
Sir?
Yeah. Should I repeat the question, Kaushik?
Yes, sir. There's a little break in the voice. If someone's repeating.
So what I'm saying, I have taken B bar vector. Praneeth, are you there?
Yes, sir. There.
B bar vector as is of unlimited length I have taken, and A bar vector as a limited is a vector of limited length I have taken. Now what I'm asking you, if I interchange these two, in place of A bar I wrote B bar, in place of B bar I wrote A bar. That means I have taken A bar as of a unit a vector of unlimited length and B bar is of limited length. Then how this conclusion changes, that's what my question is. In place of A bar, B bar comes. In place of B bar,
So, length of orthogonal projection of B bar on A bar, sir.
into?
Then we should take the length of orthogonal projection of
A
B
bar.
bar on A bar, sir.
On A bar.
Here we took A bar on B bar, sir.
That's okay. A bar on B bar changes to B bar on A bar. Into what?
Sir, into mod of A bar, sir.
That's
Mod
it.
of A bar.
That's it. That's it. This is the geometrical meaning of it, and the dot product is, in fact, is very easy in solving the problems. Its application is also easy because there are no restrictions. All the algebraic formulae can be comfortably used. All the algebraic formulae. What I mean to say by algebraic formulae, like A plus B whole square is there. A square plus B square plus 2AB. Here it can be comfortably used. A bar plus B bar whole square, you can use straight away. So here, one more very important point and simple point with which I will be closing the session is that whenever you have A bar square or A bar dot A bar, come on, apply the formula mod A bar into mod A bar, mod A bar into mod A bar into, in place of theta, what is to be written? In place of theta, what is to be written? What is the angle between two like vectors, please? What is the angle between two like vectors? Like vectors means the same vector. No, angle between them will be 0. What is cos 0?
0, sir.
What is
1.
1. So cos 0 becomes 1, and the very important one in solving the problems, what we use is A bar square is equal to mod A bar square. Very important, please. A bar square is equal to mod A bar square. You will get this property only in the scalar product, but not in the vector product. Very, very important property, what I'm saying. Very, very important property. What I'm saying, why I'm saying it is important. Without this, many problems cannot be solved. So whenever you want to find out modulus of any vector in solving the problems, I repeat, whenever you want to find out the modulus of any vector, then you have to start with its square only. You have to start with its square only. If you start with its square, you can remove the modulus and you can write it as A bar square. So A bar square without modulus, A bar square is equal to mod A bar square with modulus. Both are equal. Both are equal. So whenever the modulus of any vector is to be found out, you start with the square and then remove the modulus and split it. Because of this reason only, every algebraic formula can be comfortably transformed to the dot product, like A plus B whole square, A square plus B square plus 2AB, A minus B whole square, A square plus B square minus 2AB, A plus B into A minus B, A square minus B square, and what all the algebraic formula are there, they can be comfortably utilized here. So this is the most important point, and if you ask me to give star rating to this, I'm leaving only 1 star and I'll give 5-star rating to this. This one, A bar square is equal to mod A bar square. 4 stars I'll give. That much important is it is in solving the problems.
Okay.
Okay?
Okay, sir.
So this is about the dot product, and we will see the properties of this dot product or scalar product in the next session, and thereby we will be working out the problems also
Okay.
on this dot product. So let us close the session with this one, and in the next session we'll see the properties and problems.